All right, y'all. So everybody should have picked up the Unit 6 notes packet and the Unit 6 choice board. So first things first, I just wanted to point out that you have a homework 6.1 Delta Math that is due next class, so that'll be on 122. And your choice board topic 1 will also be due next class. So you should have plenty of time in class today to get both the notes video and the topic 1 choice board done, and then probably even get to start your 6.1 homework, if not finish it. I will be around today. Like, I will have my computer and my phone, so if you need to send me a message on Schoology if you have any questions, feel free to do that. Okay, so first thing, we're going to go to page 2, and we're going to talk about systems of equations. So systems of equations, y'all have talked about before. A system is when it consists of 2 or more equations or graphs. So the solutions of a system are always the intersection points. And they're written as ordered pairs. So basically we're looking for where 2 or more graphs are going to cross each other, and wherever they cross, that is going to be your solution. So first thing we're going to do is solve these by hand. So what we're going to do is a method called substitution. And these are going to be pretty basic. We're not going to go like too difficult with these. They should be pretty straightforward to solve, hopefully. So because both of our first two examples are already in y equals form, then because they both equal y, then we can take both of the systems that were given and we can set them equal to each other. So we would have x squared plus 5x minus 10 equals 2x plus 18. So now that we've set them equal to each other, our goal is to get everything to one side because that's how we're going to solve a quadratic function, just like we did last unit. So I'm going to go ahead and move everything from over here and move it over here. And from here, we just want to combine like terms to get everything. So this on this side, these will cancel, and so will these. These two right here are going to be like terms. So we're going to go ahead and add those, and then these two will be like terms. Okay, so we'd be left with x squared. 5x minus 2x would be plus 3x. Negative 10 minus 18 would be negative 28, and that equals 0. So our goal was to make it equal 0, so now we can solve this, and most of them should be solvable this way. Solve this by factoring. So I'm going to go ahead and factor and figure out what multiplies to negative 28 and adds to 3. So think about that for a second. All right, so for negative 28, it should be 7 and negative 4. So I'm going to go ahead and use the shortcut and go ahead and just do x plus 7, x minus 4 equals 0. All right, so now from there, let's solve these and solve for x. So we're going to have, for this one, x equals negative 7 and x equals positive 4. So remember, it switches the sign. Okay, so now we have two x values, but we need to write our solution as ordered pairs. So I'm just going to go over here, and we have negative 7 comma blank. We don't know what the y value is yet. And we have 4 comma blank. So our next step is to plug these x values in to get our y values. So you can plug them either into the first one or the second one. It is completely your choice. You'll get the right answer no matter which one you choose, but it's going to be a lot easier to plug it into this one, the 2x plus 18, so that's what I'm going to go ahead and do. So for x equals negative 7, I'm going to plug in, we have y equals 2 times negative 7 plus 18. And then we're just going to go ahead and solve that, do that math. So 2 times negative 7 is negative 14 plus 18. And that's going to equal positive 4. So that should be your y value for negative 7. Okay? So we're going to do the same thing for x equals 4. So we're going to still plug it into that same equation. So y equals 2 times 4 plus 18. This way we don't have to deal with squaring anything, don't have to worry about like parentheses with a negative or anything like that. So we're going to go ahead and solve this. 2 times 4 is 8, plus 18 is going to be 26. So that would be your y value. All right, and those should be your solutions. You have 2 solutions for this one, for that system of equations. All right, we're going to go ahead and solve number 2. So first thing, if you notice, this one is set equal to y, but this one is, the second one is not. So first thing we're going to do is make sure that it's in y equals 4. So I'm going to go ahead and add 3 to both sides. So that makes it y equals x squared minus 4x plus 3. Okay, so now we're going to do the same thing we did from the previous problem. So I'm going to go ahead and set x squared minus 4x plus 3 equal to x squared minus 1. And then we're going to go ahead and get everything to one side. So I'm just going to move from over here, minus x squared plus 1 minus x squared plus 1. And then let's cross out our 0 pairs. So this will be 0, this will be 0. And then we have our like terms over here. These cancel out also. And so we're left with negative 4x plus 4 equals 0. All right, so there's kind of 2 ways you can do this. You can factor it or you can just isolate x. I'm going to do that because that'll be quicker and easier. So first thing we're going to do is subtract 4 from both sides. So we'd end up with, and I'm going to move over here, we're going to have negative 4x equals negative 4. And then we're going to divide both sides by negative 4. So we're going to have x equals 1. All right, so that's our x value. We only have 1 this time, but we still need to find our y value. So we're going to do that the same way we did for the previous problem. We're going to plug 1 into one of our equations. Again, it doesn't matter which one you do. You should get the same answer for both of them. I'm going to plug in it into the x squared minus 1 just because that one looks easier. So we have y equals 1 squared minus 1. 1 squared is 1. 1 minus 1 is 0. So our one solution would be 1 comma 0. So that would be our answer. All right, feel free to skip this next part if you don't think you need to see another example, but I'm going to walk through number 3. So we are already, both of these are set equal to 0. Set equal to y. So we're going to set both of them equal to each other. So we'd have x squared plus 10x plus 26 equals negative x squared minus 10x minus 22. And I'm not going to trick you. I'm not going to really ask you to solve these by hand if they're like super difficult to solve. Really, if they're like straightforward like this, then I'll ask you to do that. All right, let's get everything to one side. So I'm going to add x squared, add 10x, add 22, and do that to both sides. All right, everything on the right side should cancel because that was our goal. So that cancels, that cancels, that cancels. And then we're going to go to the left side. So we'd have 2x squared plus 20x plus 48. And that should equal 0. All right, so let's factor this, and that's how we should solve it. So first thing we need to do is factor out a GCF. So our GCF would be 2. And we're trying to figure out what's going to multiply to 24 and add to 10. So in this case, that would be 6 and 4. So we'd have 2x plus 6, x plus 4 equals 0. And when we're solving this, the GCF, because it doesn't have an x, it really doesn't matter with what your solutions are. So all we're worried about is this x equals negative 6 and x equals negative 4. So remember, it's the opposite sign. And then we're going to go ahead and plug these in. They're kind of both ugly equations, like they're not like the best to plug something into. So I'm going to plug it into the first one just because there's no negatives. So it kind of like makes it a little bit easier. So I'm going to plug negative 6 in first. And hold on, let me set up our ordered pairs. So we're going to have two solutions here. So we're going to have negative 6 comma something and negative 4 comma something. All right, so let's plug that y value in. So plug negative 6 in everywhere there's an x. So we're going to have two places to plug it in this time. So negative 6 squared plus 10 times negative 6 plus 26. So that equals negative 6 squared is going to be 36. 10 times negative 6 is negative 60. And then plus 26. And then we're just going to add all those together, and that's going to give us 2. So for negative 6, it'll be 2. And remember, your solution should always be written as ordered pairs. All right, let's do negative 4 now. So we're going to plug negative 4 in the same way we did before. So negative 4 squared plus 10 times negative 4 plus 26. And don't forget to put parentheses, especially here, because if you square it without parentheses, it'll give you a negative, which will give you the wrong answer. So we'd have positive 16 minus 40 plus 26, which is also going to equal 2. So those would be our two solutions. Okay, so that's kind of like the bulk of the lesson. And then I'm just going to show you how to do it graphically, and this is going to be where it flies by. So there are like multiple different types of solutions you'll see. So we're on to the next page, page 3. So anywhere that the graphs cross, you're going to have that number of solutions. So if you look, no solution is going to be when these graphs don't cross at all. There's nowhere that they cross. So leave yourself that little note. If they never cross, there is no solution. One solution, we have quadratic and a linear function that touch just once. We saw that on the other page with the solving by hand. Two solutions, so these are two different examples. You have a quadratic and a linear. They touch in two spots. And then you have a circular graph and a linear graph. They touch in two spots. Three solutions, you have a quadratic and a circle that touch in three spots. And for solutions, you have a quadratic and a circle that touch in 4 spots. All right, so if we're looking at number 1, this graph is a quadratic and a linear. It's already graphed for you. We're literally just looking for the places where they cross and then saying what the ordered pairs are. So we cross right here and right here. So that first ordered pair where we cross is going to happen at 0, -3. And then the second one crosses at 4, 5. Okay? So on to the next one, if you look at these two graphs, neither of these are ever going to touch. So we have the blue graph, and then we have the green graph. They never touch each other, so that's no solution. All right, and then finally, this is where y'all are going to be so excited because you get to use the graphing calculator. You get to use Desmos. So for these, you just literally need to type them into Desmos and look where the two graphs cross. So I'm going to go ahead and go over to Desmos. And for number 1, we're going to type it in. You don't have to type the y equals. So I'm going to type in x squared minus 12x plus 39. And that's going to be my red function. And then y equals 4 is going to be the blue function. So all we're looking for is where these two cross. So they cross at 5, 4 and 7, 4. So where the red and the blue cross each other is going to be our answer. So 5, 4 and 7, 4 should be what you have as your solutions. Both written as full ordered pairs. All right, let's do a couple more examples. So let's do number 3. So we're going to skip number 2 and go to number 3. Clear these out and type them in again. So number 3, we have x plus 2 squared. Oops. Oh, okay, if I could read, it's cubed. So let's change that. So that is our first function, and then x squared is our other one. So what we're going to do is just look where they crossed. So green and purple cross in one spot. You can like zoom out and see that it's only one spot. And it happens at -1, 1. Okay. Let's do number 4. So I'm going to go back to Desmos, type them in. So this one's x squared plus y squared equals 9, and y equals x minus 5. All right, so we've got a circle and we've got a line. So these two are never going to touch each other. So if they never touch, then it's just no solution. All right, and we're going to do one more and we're going to see what this one looks like. We're going to do number 5, and then I have the key posted. So if you want to do 2 and 6 to go back and like just check your work, you can do that. So number 5, let's go back to Desmos and plug it in. So we're going to have y squared equals x squared plus 9. And then we're going to have x squared minus 3. All right, so we've got a really funky looking graph here with the blue, but all we're still looking for is just where these graphs cross each other. So green and blue, look for those intersections. And they're not pretty spots, and they're not always going to be. So we have 1, 2, and then 3 where they cross each other. So those 3 points are going to be our 3 solutions. So I'm going to go ahead and go back to our paper. So we have negative 2.646 comma 4. We have 2.646 comma 4. And we have 0, negative 3. So we cross in 3 spots. Okay, so that's it for the notes. That's all we're going to do for today. So go ahead and do number 2 and 6 if you want to try. Just type them into Desmos and tell me where they cross, and you can check your answers on Schoology. Other than that, feel free to move on to your choice board. So there's 4 options today for your choice board, and you should be able to finish it before you leave. You do need to show your work for, I think on each of them it says to show your work on 2 of them. So make sure you read the directions clearly and show your work for those so you can get full credit, because I just want you to do at least 2 by hand. Okay, so please feel free to message me if you have any questions. Other than that, have fun, get your choice board done so you don't get behind, and you could probably get your homework done too, which would be great. All right, y'all, have a good day.